This talk is about coroutine's flow framework, which was recently introduced. And the title of the talk is Flowing Things Not So Strange in the MVI World. So who am I? I am Garima Jain, and I work for a company called Over. It's a South African-based company. It has an app called Over, wherein you could put some text over images, text over video, and all those things. So who is this talk for? So how many of you, this is a raise of hands kind of a question, how many of you have done some reactive programming in RX? Almost the whole room, that's awesome. How many of you have experimented a little bit with coroutines? That's great, a lot of people. How many of you have read a little bit about the model view intent pattern? Again, many people, that's awesome. And how many of you have watched this show called Stranger Things? Again, a lot. That's great, but a bummer, there's not going to be a lot about Stranger Things, but we'll try. So what is this talk about? So we're going to divide this talk into multiple chapters. The first chapter is going to be a brief introduction to coroutines and the flow framework. The second chapter is going to be a bit about channels and their comparison to flows. Third chapter is going to be a little bit of introduction to MVI. And the fourth chapter is going to be, we're going to try to take an example and implement it using RX Java, and then try to convert it side by side to use the flow framework. And finally, we'll summarize it a bit. So this brings us to the first chapter, that is the flow. So coroutines. So what are coroutines? Coroutines are lightweight threads which can run computations without blocking our main thread. Coroutine can be suspended at a particular line, and we can then resume operation at a later point of time. There are a bunch of concepts related to coroutines. The very first one is coroutine scope, and as the name suggests, a coroutine scope is the lifetime of a coroutine. We have some coroutine scopes available out of the box for us. For example, view model scope. View model scope is the scope of the coroutine. For example, if a coroutine is started in the scope, then when a view model is destroyed, then this coroutine would get cancelled and all of its children. Similarly, we also have lifecycle scope that we can attach to any lifecycle owner. We also have something called coroutine builders. Mainly, I'm going to talk about launch and async. So launch is a sort of fire and forget type of a coroutine builder. We launch a coroutine, and then we can get a job instance, and we can put some invoke on completion and those kind of things on that job. But async is a bit different. If we call await on this coroutine builder, then we can get the result there and then, and it is going to suspend when we call .await on it. So this brings us to a concept called structured concurrency. So as I mentioned, when we launch a coroutine within a scope, then when that scope ends, this coroutine gets cancelled. So we can launch a coroutine only from a scope. So this kind of a concept is called structured concurrency. It was not there at first when coroutines were launched, but then it was brought on later, because even though coroutines are very lightweight, but we cannot just fire them and forget about them. So this brings us to the next thing, that is channels. What are channels? So now we have a bunch of different coroutines, but how do we talk among those coroutines? So that is where channels come into picture. Using channels, we can communicate between different coroutines. So channel is sort of like a blocking queue. We have a big pipe, and we can put something in there. When we send something into the channel, we're going to suspend over there until there is a receiver at the other end to receive that particular thing. And similarly, if we are starting to receive something from the channel, we're going to suspend until somebody sends something into the channel. So this is the concept of channels. Next is flow. Flow is sort of a cold asynchronous stream of data. When I talk about flow, you can think of flow as observables or flowables which emit data at different point of times as a stream. Flow under the hood They utilize coroutines, and certain flow operators are based upon channels. Flow APIs recently became stable since 1.3.0, and now we are at 1.3.2. So how do we create, just like flowable and observable, how do we create a flow? How do we emit certain data? So we have a bunch of flow builders, for example, flow off, wherein we can pass in some values and it will get converted into a stream. We have as flow, we can convert an iterator by calling .as flow on it. And then this one is an important one. This one is a flow which takes a lambda. This lambda is the flow collector. And on this flow collector, we can call .emit. So when we pass in this flow collector, and we can emit any values we want, whenever we want to emit something, we're just going to call .emit, for example, 1, .emit 2, and so on. Channel flow we'll come back to later. So we have a bunch of operators like map, filter, take, etc., just like reactive world. And we have a bunch of terminal operators. The most important one is collect, that we are going to talk about. Collect is mostly like subscribe. When we call .collect on flow, we actually get data from that flow. So let us look at this small code snippet to demonstrate flow. So we have a run blocking coroutine builder over here. So this run blocking just says that whatever, using structured concurrency, whatever is inside this particular block, it's going to end when this block ends. So we create a flow over here using the flow builder. We iterate from 1 to 10, then after a delay of 500 milliseconds, we're going to emit certain values into this flow. And we're then going to add a filter operator, which is only going to emit even values, and then we're going to collect it and print it. So now let's try to run this. So as expected, only even values are printed. So there are a bunch of constraints, a little more theory, but we're going to come to the code next. So there is context preservation, and then there is exception transparency. Let's talk about context preservation. So when I'm talking about context preservation, you can, in your head, compare it a little bit with subscribe on. So we're creating a flow over here with values 1, 2, and 3. We're mapping it to +1. And then we're saying flow on context A. And when we do this, this map is going to be executed in context A. And also this flow off is going to be executed on context A. Now, if we compare it with subscribe on, we would think that this particular next line, this is also going to get on context A. But this is not the case with flow on. In this, context is preserved. So we can think of it like, for example, if the data layer started here, somewhere here, and we wanted to execute certain operation on an IO scheduler or something, we do not want that context to be leaked outside of our data layer into our domain layer or something else. We do not want that. So using flow on, context is preserved within there. And then this particular next line, it becomes a pure operator without any context yet. And then we use this with context dispatcher main. So this makes everything inside this block plus everything pure above it to execute on main thread. So this is the context preservation. So this is something to keep in mind. And that brings us to the second chapter, that is consumer do you copy. So let us try to look at a snippet to create a channel. So again, we have the same run blocking construct. In this case, we launch a coroutine over here, and inside that coroutine, we create a channel using the produce builder. Inside this produce builder, we send a value 1 and print we are hot. And we capture this coroutine inside a job. And on completion, we're going to print completed. And finally, we're going to print done waiting after a second. So let's try to run this. And one thing important to note over here is this channel, we're actually not yet consuming this channel. And still, you see, even though we are not still consuming anything from this channel, still we are hot as printed. Still there is a coroutine running at the other end. Still the channel is open. So this is why channels are hot. Even though we are not consuming them, they're still running. So let's try to consume it this time. So we put a channel.consume each this time. And you will notice, like last time, this completed was not called. So that particular coroutine kept on running. And this time, because we have consumed, then only this coroutine stopped. So you see that like it is easy to make. It is a simple mistake that anybody can make. So let us compare this with flows. Let's launch a coroutine and create a flow instead, and print we are cold and emit 1 into it, and try to invoke on completion completed. So let's try to run this. So you see, we are cold is not printed in this case because flow is cold. Until unless we start collecting from this flow, then only it gets executed. So let's try to collect from this now. So you see, when we started collecting, then only we are cold gets printed, and then only it started executing. So let's try to compare channels with the world of upside down. So as I like to believe, channels are a pathway to a different dimension, perhaps upside down. So if a channel is open, another dimension, we can call it a coroutine. If a channel is open, then another dimension exists, a coroutine exists. Existence of this another dimension could be dangerous. This coroutine, which is running in the wild, is dangerous because it could use up some heavy resources. So as I say, channels are easy to make mistakes with. So the contributors of coroutines, they have decided to keep channels as an internal level API, and they're building a bunch of wrappers around it. So channels are going to be there, we are going to utilize it, but they're going to write a bunch of wrappers and operators on top of it once, and then we can use it again and again. That brings us to the third part of the talk. That is the model view intent pattern. This is going to be a brief introduction to model view intent. So model view intent, as I like to say, model is a state and intent is the intention of user. So what is the state view intention? We have a user, intent, state, and view. So user interacts using an intent. Intent changes the state. State is updated on the view, and that view is shown to the user. This is a cycle of model view intent pattern. And how do we implement this cycle using MVI on top of a model view model pattern? So we send an intent to view. These view sends a bunch of actions to view model. These actions are converted into one or more results. Those results go into the reducer. Reducer takes in the previous states and creates a new state, and the state is shown onto the view. So what we're going to do is we're going to take this, implement it in reactive, and we're going to do it in 5 parts. The first part is sending actions to the view model. Second part is converting each and every action to a stream of results. Third part is taking the previous state into the reducer and creating a new state. Fourth part is going to be view observing the state. Fifth and final part is going to be plugging various pieces inside the view model. That is how action gets converted into result goes into the reducer, and like this sort of chain that lies into the view model. So these are the 5 pieces. Let's start with the 4th chapter, that is migrating an RX MVI app to use Flow. In order to do that, let's take an example. For example, this is a GIF of a demo. We fetch a bunch of characters from server, then we load this data, and what we can do is we can click on a description for a particular character and load that. And also, we can call a pull to refresh on this particular view. So this is the demo that we're going to implement, and as I just mentioned, this is going to have various actions. So I would request you one thing, like there is going to be a bunch of code. So do not try to read all the code. I'm going to point out the important pieces. So this is the action class, and there are 3 actions: load data, pull to refresh, and load description for a particular character. So this is our view model API, wherein we call on action and send a bunch of actions into the view model. This is how it is written in Rx. Let's convert into flow, because there is nothing stream of data going on over here, so it remains the same. So this is how we can pass a bunch of actions into the view model. We can call .action on it. We can pass main action.load data. We can attach a listener and then pass this action, and so on. We can attach another click listener. So this all part remains the same. So that brings us to the end of the first part already, and we are happy. So this part is a bit important. So each action can get converted into a bunch of results. For example, loading gets converted to loading, loading error, loading complete. Similarly, pull to refresh, and similarly, description result. So we had this particular diagram, which we saw earlier. In order to convert our action to results, let's take the logical layer and data and distribute it into a repository layer and a network layer. So we're going to try to implement these layers separately and try to convert them. So firstly, data layer, how is it going to look? We are going to use retrofit for this. We are using this characters API to get a single of list of character something. And then we have our repository layer. For this demo, I'm not using the cache part. It is just going to hit the API, but we could also use a cache part over here. So what it is doing in this case is it's taking a single, it's using the API part and returning a single. So this is the code that is going to be on our view model. So we have a stream of actions. What we're going to do is we're going to take that stream of actions and take each action and convert it to multiple results. So this load data action stream is a bunch of actions coming in. We're going to do an observe on this and do a flat map, and then we call the repository to get characters, then we map it to a successful result, then we start with loading, and on error, we're going to navigate to show a snack bar, and finally, we are going to emit a result of error. So let's go one by one and convert these into their coroutine/flow counterpart. So this was our Marvel API. So we were returning a single over here. So how do we convert it to use coroutines? We can attach a suspend function over here, and instead of returning a single, we can return the object itself. So this has started existing since retrofit 2.6.0. Next, we had this repository class. It is also, if you notice, returning a single. So in this case as well, what we can do is we can attach suspend over here. A suspend function can call another suspend function. So we have this other suspend function. We can sequentially return our characters from here also. Previously, it was a single, and it was like we were calling subscribe on it, and all those, like there was a chain, but now it becomes a bit sequential. So this was our Rx view model that we just talked about. Let's try to convert this into flow. So the return type of this function, flowable, becomes flow. This, we are going to do a flat map over here that is corresponding to flat map merge. Then what we do is, inside this, we return a flow over here, which we use this flow builder, and we can emit, like as I told you, we can sequentially emit different values. So what we are going to emit loading. We are going to use the repository to sequentially get characters. We got the characters, then we can emit it. And finally, we can use the catch operator to get some errors and navigate and emit. Like this is a one-to-one sort of a relation. If you feel that it is not one-to-one, we can also do this. So we can create a flow at the top layer itself. Or like if you wanted, we can also put this, like instead of main repository.fetch characters, instead of it returning the data itself, it could return a flow. And when will that happen is, when we want our repository to emit multiple data instead of just one. For example, it could happen in the case of caching, where we might want to observe the changes in the database. So then we can hide this flow behind the repository itself, and then we can call map and on start. It has sort of a one-to-one relation. So we just converted our loading result, that is the converting a loading action to multiple results, to use flow. Similarly, we can convert our pull to refresh to use flow, and also we can convert our description to use flow. So the next part. So as I mentioned earlier, what happens is we have a bunch of actions, we have a stream of actions, and what we need to do is we need to divide that stream according to a particular action, and then convert each action into multiple results, and then combine that and merge them into a single stream of results. So this particular piece of code does that in Rx. Let's convert this into flow. What I'm doing here is, like, I create an extension function on flow, and I create this function action to result transformer, and instead of returning a flowable, I return a flow again. So there are two important things to note over here. First is the publish, and second is the merge operator. So let's first talk about the merge operator. So at the time when I was experimenting with this, I didn't find any merge operator. But with coroutines, creating operators is comparatively easy. So let's try to create one. So let's create this merge operator. Let's go one by one. So what I'm trying to do over here is, like, I have one flow and I have another flow. I want to merge the items emitted from both of these flow into one. So I create an extension on flow. Why I've used channel flow over here, I'll come back to this later. So firstly, what I do is I collect from this coroutine and send it. So I launch a coroutine and I collect from this particular flow and send it to this other channel flow. You must be wondering why send and not emit. So this is the API of channel flow. This is similar to emit. So we collect from the current flow and send it to this new channel flow. Similarly, we'll launch another coroutine and collect from this other flow and send it to this particular channel flow. So this is how we collected the items from both the flows and send them to one. And now, why did we use channel flow? Because, like, if you remember, channels are used to talk between different coroutines. So if you see here, we're launching two coroutines, and we're talking between different coroutines. And if we do not use channel flow over here, this app will crash, because we cannot just, like, talk among two different coroutines without using any particular construct. So this is why we use channel flow. So we were here, we did the publish. The next is we did the merge. Next is the publish operator. So thankfully, David Carnot created some extensions, and that particular library has this publish operator. But a good friend of mine from the community, Manuel Vivo, he pointed out that we need not use this external dependency as well. What we can do is we can instead use this broadcast in view model scope, which what this does is like, to understand that, let's iterate a bit back. So what publish operator does is it takes a particular stream and it dumps that into a channel, or you can say it dumps that into a particular subject, so that it becomes hot. Because when we divide our stream into multiple actions, according to multiple actions, we do not want to subscribe to it again and again. So we want that same instance of actions, action stream. So the same thing happens with this dot broadcasting. It creates a channel, it dumps everything, it becomes hot, so it is not started every time, it keeps on running. And that is what we want to achieve over here. And we expose it as a flow. So that's done. So I just talked about taking a stream of actions and dividing them and then merging them back. We can also do this instead. What we can do is we can take a stream of action, attach a big when statement, also attach a big flow outside, and then according to a particular action, we can keep on emitting various loading and loading complete. It becomes a bit sequential in this case, and we can do this because we are emitting a single from our repository. That is why we can do this. So what we just did is, this was our reactive diagram. We just converted this, this part from view model back to this view model. It becomes a bit sequential because we are not subscribing to a single data type. We are not subscribing to that. So we converted this whole layer into a sequential kind of a flow. But like as I mentioned, that if we have a cache, we cannot just make it sequential, and we need a bunch of items emitted. So in that case, we can just keep this this part from repository to network sequential, and like whenever we have a single or a maybe, then in that case we can use suspend functions. And if we have a flowable or observable, in that case we can actually use flow. So our flow is going to be, this coroutine part is going to be limited to our repository layer, and above that we can use flow. So since Room 2.0 alpha, we can actually return flow itself from Room and observe various changes. So that is how we can achieve this kind of behavior wherein our repository emits flow. So that brings us to the end of this part. Next part is reducing results to new state. So let's take a look at that. This is our state. Let's not get into the details of that because we're not here to talk about state modeling. And this is the reducer, which takes in a previous results and creates a new state. So we need not go into the details of that. This is the RX reducer, and this is the flow reducer. They remain the same because there is nothing streams like going on over here. So this basically remains the same, and we have concluded this part as well. We're happy. So the next part is state stream. So we have this state which changes over time, and our view, it needs to observe that state. So what we can do there, what we usually do is, because our view is lifecycle aware, then what we do is we create a state live data. Whenever the state changes, we put something into this live data, and then on the view side, we observe this live data. And finally, on the render function, whenever something changes, we pass it to the renderer, and that render function is called. So if we want, we can keep on using live data, but there is a concept called conflated broadcast channel. We could also use this, which is actually a counterpart of a subject, behavior subject, you could say. So what we can do is we can create a conflated broadcast channel and expose it as a flow to the outside world. Inside this channel, whenever the state would change, I'll put something in this channel. And on the view side, we are going to collect from this flow. Because we need to expose only a flow, not channel, because channels are dangerous. So whenever there is a change in the state, we are going to call this render function. So, but this dot collect, but this collect can only be called from a coroutine scope. So let's add a lifecycle scope in it. Let's launch a coroutine, and now we can collect from this channel. So this lifecycle scope, it started existing since lifecycle KTX 2.2.0. We can use this. So conflated broadcast channel. So how is it different from a simple channel? Firstly, it is a broadcast channel. It can broadcast to multiple receivers. Then, as the name suggests, conflate means combine. So what it does is, it takes in a bunch of values. It combines all those values, so a receiver only gets the recent value. And it sort of behaves like a behavior subject, because it caches one value, and like the receiver can get that value whenever they are consuming it. So the render function, it basically takes a state and renders that onto the view. We need not get into the details of this, because that remains the same. This brings us to the end of the state part. And finally, let's plug in various pieces that we just created inside the view model. So plugging in various pieces. If you remember, we had this view model interface wherein we had this on action method wherein we can pass a bunch of actions. So how do we implement this? So in the reactive world, what we would do is we'll create a publish processor, or you can say a subject, and we will keep on adding actions into this subject. And that is how, like, and we can then create a stream of actions by doing this. And we can achieve the same thing using conflated broadcast channel, because I just mentioned that it behaves like a behavior subject. And that way, whenever there is an on action, we are going to offer something into this broadcast channel and finally expose this broadcast channel as a flow. So this is plugging various pieces into the RX view model. This is the process action function, wherein we take a stream of actions, we call a compose operator on it, which converts our actions into result. And then we call a scan operator, which saves the previous state. And finally, we call reduce function, passing in state and result. And then we subscribe to it. Whenever the state changes, we post values to the live data. And finally, I've added this small extension function, which basically what it does is it is an extension function on disposable. It adds it to composite disposable, and when our view model is destroyed, then it can dispose of our disposables. So let's try to convert this to use flow. So let's firstly go by actions processor. Action processor becomes action flow. Compose, as we just talked about, this becomes broadcast in because we need to publish and merge. And then we have scan. Scan remains scan. We have subscribe. Subscribe is collect. And live data remains the same. And this bind to life cycle, it is to dispose of our disposables. So this view model scope.launch does the same thing. It disposes of our coroutines, or you can say cancels our coroutines. So we have successfully converted this particular small chain to use flow. This brings us to the end of the part of converting or migrating an RX MVI pattern to use flow. And congratulations on completing this. So let's summarize a little bit what we just learned. As I mentioned, so if you have something which is emitting a single or a completable, then we need not make it reactive, or we need not emit various values. We can just use a suspend function. It will make our logic a bit simpler, because like using reactive over there in the case of single and completable is a bit of overkill, and we would love to get our results there and then instead of like creating a chain in that case. But if you have something stream-like, for example, emitting various values from cache, etc., then you can use flowable, observable, or in the coroutines world, you can use a flow. Behavior subject is conflated broadcast channel, scheduler's dispatcher, and so on. This is the mapping of bunch of operators. There must be many more. Subscribe on is a bit different from flow on. We just learned that. Let's answer a bit of common questions first. So why flow? Why should we use flow? To answer this, I would like to say that flow is the shiny new thing. We have RX, we want to look at flow. But jokes apart, Flow has first-party support. It is built on Kotlin. Android libraries have now started to support Flow, for example, Room. And by using Flow, or I would say coroutines, we can at least simplify the logic where there is no need of emitting multiple values. So the complexity of business logic reduces. And hopefully share more business logic because of multi-platform and stuff in future. So another question could be like, I have a reactive app. How do I start? So there is an interop library. We can start piece by piece. You can use this. There is a single.await, flowable.await, and similarly the other counterpart to convert a single into coroutines flow. So we have a bunch of goodies. and we can do interop. So if we have a non-coroutine API and we want to convert into coroutine, yes, we can do that. We have a construct called suspend coroutines. We can read more about that. What about testing? Yes, we can do testing as well. Just like test scheduler, we have something called test dispatcher. We can use that, and we can call all those goodies, functions like advanced time by and all those things. And we can set the main thread to use various dispatchers and all those things. Perhaps inject a dispatcher provider, just like injecting a scheduler provider. We can do all sort of things, and yes, we can do testing. So what's next from here? Like, these are a bunch of good references that I found really useful. There is this flow extensions library. There is this coroutine binding, which can, if you have used RX binding in the past, wherein you can convert various like scroll events or refresh listener to emit various values, this is a similar thing for using coroutines. There is a good talk. There is data flow is interesting. Like the thing that I just mentioned, conflated broadcast channel, it is soon going to be named as data flow and exist as a subject for the flow world. Like there's a proposal for that, but let's see what happens. There's this good guide. There is like flow versus channel, a bunch of goodies. Like there's also the demo project for this talk exists at my GitHub repository. You can check that out. And finally, a bunch of references and acknowledgements. Would like to really thank Manuel Vivo and Hennes Dorfman to review the code of this presentation. And my team at Over, my husband, who is always in the audience, even though he's an iOS developer. And very good blogs by Roman Elizarov, and like you can check all those out. And finally, thank you, and if you have any questions, thank you.
Does anyone have any questions?
Thank you.